3, lesson 7, we're looking at two different kinds of XY relationships. We're going to look at XY relationships that show a constant rate of change, and then we'll also look at XY relationships that show a constant of proportionality. So look in the top left box, you'll see a brief explanation of both of those. Let's first talk about constant rate of change. So when you're looking at constant rate of change, all you're looking at is how the Y value changes in response to a change in the X value. So for example, let's say that you already have $100 in a savings account and you decide that you're going to add $25 a month to that. Then as the months change by 1, your dollar amount is going to change by 25. So your dollar amount is responding to a change in your time. So one key thing to note here is that when you're talking about your X value, your X value is always your independent variable. It's the one that's basically in charge. You're making the decisions. So for example, let's say in the case of a job where you're making $10 an hour, your hours determine your pay, not the other way around. So your hours would be your X value. Your Y values are your dependent variables, which simply means whatever Y is depends on X. So those are just sort of given. Your X values are always your independent values and your Y values are always your dependent values. When you have a constant rate of change, what you're looking at is your change in Y as it relates to your change in X. When you graph a relationship that has a constant rate of change, you'll have a straight line. It may or may not be proportional, so it may or may not go through 0, 0, but it will be a straight line because it's a constant rate of change. It's either rising or falling at a constant rate. Now, when we talk about constant of proportionality, that's obviously going to involve a proportional relationship, so when graphed, it will go through 0, 0. And so we know that in proportional relationships, when we write those in equation form, we're looking at Y equals some value times X. And in math, we call that the constant of proportionality, and we'll refer to it with the variable K. So that K represents your constant of proportionality, and it's just whatever number you're multiplying times your X values to get your Y values. Now, if K is what you're trying to figure out, we can rearrange this equation so that the K is by itself by simply dividing both sides by X. X over X is 1, so we can see that Y divided by X equals K. So if you're trying to figure out the constant of proportionality in a proportional relationship, you can simply take any of your Y values and divide them by their partner X value, and that will give you constant of proportionality. Now, in a relationship that's proportional, your constant of proportionality will also be your constant rate of change. Those will be the exact same thing. But when you have a constant rate of change, it may or may not be proportional. It just depends whether or not it goes through 0, 0, or if 0, 0 fits the situation. So look at this first example. Across the top, we have X values that are referring to rides taken, and then we have Y values that are referring to money spent. And if we want to find the constant rate of change, a good way to think about that is your change in Y related to your change in X, and your change in Y divided by your change in X. So what you're asking yourself is, as Y changes from one value to another, how is X changing? And you can see that if you look at this table, if you just look at the first column, it might appear that every ride is $9.25. But if that were the case, then we know that two rides would be $18.50, and you can see that's not what it says. So there must have been some other built-in fee. That's this price of admission. So we can tell that we don't have a proportional relationship because there's a one-time admission price. So we're not talking about a proportional relationship, but we can look to see if there is a constant rate of change. So the way that we do that is we look at change in Y, and then we look at the change in X at that same point in time. So from $9.25 to $11, that's a change of $1.75. And at that same time, X went from 1 to 2. So that's a change of 1. Then we can look at the next move. So Y went from $11 to $12.75. That's another change of $1.75. At that same time, our X value went from 2 to 3. That's a change of 1. Then we can see from $12.75 to $14.50 is another change of $1.75, and at that same time X went from 3 to 4, so that's a change of 1. So we can see that the constant rate of change here is 1 75/100 or 1 3/4. So the constant rate of change is $1.75 per ride. So now again, if you go back up to that first column where it's talking about one ride, the reason it doesn't say $1.75 right there, and instead it says $9.25, is because there's some sort of built-in price of admission. We could essentially do $9.25 minus $1.75 and figure out what that price of admission is. So that's constant rate of change. It's just change in y over change in x. Now with constant of proportionality, if a relationship is identified as being proportional, then you can take any y value, divide it by your x value, and you should get the same thing all the way across your table, or if you're looking at a graph, you should get the same thing all the way across. So we can see here that y divided by x, so 50 divided by 1 is 50, 100 divided by 2 is 50, 150 divided by 3 is 50, 200 divided by 4 is 50. So all of those y divided by x ratios give us a value of 50. So we would say our constant of proportionality here is 50. In other words, our equation is y equals 50 times x. So if we graphed that, it would go through 0, 0, because at 0 hours you would go through 0 miles. And if you were to come back up to this one, you can see that it would not go through 0, 0, because before you ever get on a single ride, at 0 rides, you're still going to have that price of admission. So it does have a constant rate of change. It would create a straight line, but it wouldn't go through 0, 0. Whereas in the case of this relationship, it would go through 0, 0, and it's therefore proportional, and the constant of proportionality is 50 miles per hour. So at this last example, so you can see in this case, this line is falling. So we have a line that has a negative slope. So if we want to talk about the constant rate of change here, we could make an XY table and just pick a couple of points. I like to try to pick points that are at exact intersections. So let's take that point right there. That's at February, and that's at 700, halfway between 600 and 800. So we could call February the second month, and at the second month it was at $700. Now let's find another intersection, so right here. And so that's January, February, March, April. It's the fourth month, and it's at $600. And I know that it's falling at a constant rate. I can tell that because we have a straight line. So I know we have a constant rate of change. So if I want to find that constant rate of change, I've got 2 points. I've got a point at 700. And I've got a point at 600. And so the way that I can figure out the constant rate of change, we also refer to that in algebra as the slope, which we designate with the variable m. So your constant rate of change, or your slope, that's going to be the exact same thing. So the formula that we use is y2 minus y1, which is going to get us the change in y. It's just saying how much did y change. So from here to here, how much did it change? And then we're going to put that over x2 minus x1. So from here to here, how much did it change? So at the y2 and y1, y2 just means what was the y value at in your second point, and the y1 just means what was the y value in your first point. So we would be looking at 600 minus 700 over 4 minus 2. So 600 minus 700 is negative 100, which is no surprise. We can see the line is falling, so we expect to have a negative constant rate of change, or a negative slope. And then 4 minus 2 is 2. And negative 100 divided by 2 is negative 50. Now let's see how that applies to this situation. We're talking about a bank balance, so dollars, compared to months. So if our slope, or if our constant rate of change, is negative 50, we wouldn't say we were losing negative $50. That negative is what indicates we were losing money. So we would say it's falling at a rate of $50 per month. And that would be our constant rate of change, or we could also identify that as our slope. And that is it for Unit 3, Lesson 7, and you're now ready for Practice 3-7.